Okay, welcome back, Sahil, to Pakka Nimbu Podcast. You appeared on the fifth episode of the podcast, and glad to have you back.
Same here, Bhavin. Really looking forward to our conversation.
To kick off the conversation, let me give some context. We were trying to record this episode for quite some time, and a few things happened. Majorly, you were shifting houses from a rented place to your own place within the same society, but still, like getting your own place. So, congratulations on that. Also, you have a new machine, and we were trying to set this up, and there were compatibility issues with mic and camera. What this reminds me of is maintaining library dependencies in software repos, where things can get quite messy. What has been some of your challenges and stories around this?
Yeah, so that is actually a very common problem. I think everyone goes through it. So what the software industry has come up with are these patch versions, minor versions, and major versions, right? So if you have 2.3.4, the point 4 at the end is a patch version. Usually,
Yeah.
changing that impacts no one at all. So the softwares update them automatically without even telling you. You're not
Yeah.
even supposed to get into it. Then there's a minor version, 2.3, the second bit. With the point 3, generally nothing breaks. It's really easy to just change the point 3 to point 4. So if today you are on 2.3.4, you can just change it to 2.4.0 and expect nothing to break. And generally, almost 99% of the time, nothing breaks. It's
Right.
quite stable. So I remember doing this for React versions in the past, for other libraries in the past, and it's seamless. It just works. Here and there, we have had bugs in the past, but very minor. A few function calls changed by mistake, and that's it.
Right.
The major issue, right? The shifting houses things happens in the major version, right? So if you're going in a library from, let's say, version 15.6.0 to 16.0,
Right.
that is when you really need to pay it a lot of attention, right? And it is not something you can just do, open your JSON file and sare versions update kar diye. No. You can't
Yeah.
really update all the versions like that. No.
Huh.
You do that and you are definitely going to have a failure. I hopefully on the build step, but if not on the build step at runtime, definitely you're going to have a failure. So you
Right.
have to be really careful with this. I remember these major version upgrades and us, spending weeks on them with React 18, right? So React 17 to React 18 was a major rewrite. It was a major overhaul of React. They did say that it is completely backwards compatible,
Mm-hmm.
but the behavior of geometry changed. The behavior of the virtual reality experiences changed when that thing changed, because it had a lot of optimizations in it, and it was a good thing overall because the whole thing sped up, right? It was a performance improvement. But to be able to tap into those performance improvements, we ourselves had to really get into React 18, understand why things changed, what
Right.
changed, and then make all the changes in our code base. So it was a more than 2 week effort. It wasn't something that we took lightly, right? And but yeah, it went without hiccups because it was very planned. So whenever there's a major library that your code base depends on, right? And then that major library, for example, for us, it is like if I list down our major libraries, it is going to be 3JS and React, right? So
Mm-hmm.
these two major libraries, whenever they decide to upgrade their major version,
Mm-hmm.
we pay a lot of attention to that. Like all the developers are in on it. All the developers know, okay, this is the change that's going out. It it is like a major release for even us, right?
Right.
Whenever any downstream software change, sorry, whenever any upstream software changes, we also make a release saying, okay, this version has been changed, and you're probably going to see these performance improvements because of that change. So yeah, definitely it is like changing houses. It does require code change, right? Luckily for us, the way our code is structured, these version changes have never taken, let's say, more than 3 to 4 weeks of effort. Like,
Mm-hmm.
uh, for example, again, I'm taking the example of React. So when React changed from version 16 to 17, or one of those changes, right? The problem that we faced was, so GMetri has a multi-repo structure, right? So because compilation of UI code takes so long, if we decide one day to put all of our code base into a single repo and then compile it and ship it, that
Mm.
compilation step would take more than an hour, which is
Okay.
not acceptable because we need to be able to compile really fast and test and compile and test, right? That cycle needs to be as short as possible. to solve this problem, what we did was we took our mega code base, right? And then we broke it down into multiple repos. And then there are layers of repos. There's a layer 1, layer 2, layer 3, layer 4. Layer 1 repos are the component libraries like buttons, like, boundaries, clicks, text, text types, and so on, right?
Right.
Those are the building blocks. Then you have the layer 2 repos. Layer 2 repos are the components for different products of geometry. So we have a set of right bars for our editor. We have a top bar for our editor. So where these building blocks are built like Legos, that's the layer 2. Then we have the layer 3 repos where you have the complete UIs coming together. So our whole portal or our whole VR view or our whole editor, right? All of those things are these layer 3 repos. Then we have the layer 4 repos, which is the final thing that we see. So all of our main code base, those are the layer 4 repos. So there's a whole pyramid of repos that we have.
Right.
Now, this makes it really easy for us to pinpoint bugs, for us to fix issues. Let us say we discover that our button or our drop down was wrong. Let's say there's a bug in the drop down where you can't see the last item because when you scroll down, in some edge case, it doesn't scroll down properly. Let's say. Now this bug is going to affect every part of geometry, right? So now it becomes really easy for us to fix because all we have to do is go to the layer 2 repo where the drop down was written, fix it there, and compile the higher version, and you are done. The problem
Right.
goes away everywhere, right? So it's great for management. Now the side effect of this is, now let's say React decides, or we decide that okay, we have to switch from React 16 to React 17. The problem is you can't mix code bases, right? Because if the downstream repo used React 16 and upstream you say React 17, things might work, but there's a more than 50% chance they won't work, right?
Yeah.
And you won't even discover this while compilation. You will discover it later. You can discover it while compilation, but then it's up to you how you want to configure it.
Right.
So that is why these changes take longer. That is why I said it takes, the worst that I've seen is 3 to 4 weeks. The reason it took 3 to 4 weeks because everyone had to go to the downstream repos, first convert that to the higher version of React,
Right.
then go one level up, then go one level up, then go one level up. So yeah, it is a big thing. It is not something that can be taken lightly, and you have to plan for it.
So let's look at this purely from the startup perspective.
Yeah.
Can't you skip upgrading a major version? Can't you delay it?
You definitely can, and we have. So in fact, for React 18, we deliberately delayed it, I think, for around 6 months. So React 18 was where hooks really kicked in, right? Earlier, everything was done using function calls and different shortcuts that React provided. Then in React 18, they moved finally to the hooks architecture. Like you can create hooks for everything.
Right.
Use effect, use layout, and so on. Right. So even we changed our code base to work with hooks. Now, we knew that going to React 18 was going to be a major overhaul beforehand because we had seen the release notes, we had seen what was going on with React. We were very in touch with it.
Right.
And we knew that this is not something that we can do without having one whole month free just for that. And we did not have the time.
Right.
So see, everyone was happy with React 17. Our clients were happy. The code was working fine. There were no major issues with React 17. And Facebook knew that React 18 is a major overhaul. And they knew that the whole world would take a few years to move to React 18. And in this particular case, there were no security issues that forced us to move fast.
Right.
It was just a performance upgrade, a developer lifestyle upgrade, and so on, right? So we had time in our hands. So I think we had, in fact, waited for 6 months after the release for us to then figure out, okay, how do we transition our release? How do we plan for it, right? So yeah, you are right in saying startups definitely delayed. And another instance is the move from React VR to React XR, right? So that was a major change.
Actually, before we go there, hold that thought. So major version upgrades are basically schedulable because they are large chunks of work and you know that it is going to be disruptive. तो आप डिले कर सकते हो 6 महीने बाद ले लिया 1 साल बाद ले लिया right you can just slot it at the right time when the teams are under lesser pressure from the feature pipeline perspective. What happens to the minor versions? Have you seen instances where minor versions basically give you hiccups while they are supposed to be smooth, but they suddenly just like do a backward incompatible change and just do a minor version change and you like rush into it.
Yeah, this happens more often than not. Uh, Minor versions by definition are supposed to be smooth, right?
Right,
But many times they are not.
right.
Luckily, what we have seen is like around 80% of the times, whenever we upgrade a minor version, and if there was an issue, we
Hmm.
catch it at the compilation step. So
Okay.
build start failing, right? And then we say, hey, what happened? Why did the build fail? Then we figure out, okay, this was changed from 10.1 to 10.2. Then we go to its release notes, and then we figure out, oh, this guy changed this, right? And it
Hmm.
is now suddenly incompatible. Then we say, okay, yeah, just stick with 10.1. When that guy releases 11, we'll just switch to it. It'll work fine. And that has happened so many times. So yeah, luckily
Right,
in the minor version world, things have gotten caught at the build step itself, or then later caught in our testing phase. So we now have a QA tester who sits and tests the whole suite
right,
before we make any release to clients, right? So
right.
that person is able to catch most of it, or the devs are able to catch it after the compilation step where we do our own testing before sending it to prod. So many times it gets caught there. Sometimes it slips through all the cracks because it's some really really edge case which you really can't test for, and then clients report it.
Hmm.
And then we figure out, yeah, because it wasn't something that a developer did, it was just a minor version change of some obscure library which is a dependency of a dependency, and and then we figure out, okay, that's the fault, and then we just move it back. That has happened more often than that has happened more than we want it to happen.
Right. So
But
how do you
yeah,
mitigate this risk? Like, is the trick to not touch the minor versions too often and then let the versions be and then upgrade them maybe, I don't know, once a quarter, like once every 2 quarters, just bump it up to the latest version and just do like 2 weeks exercise, one sprint exercise to just take care of all the libraries? Or like, do you do even more defensive where you don't touch all the libraries, but just the libraries which are deprecated? Which have gone into deprecated version, just bring them back up to a supported version. Like, what's your philosophy of de-risking your production through these upgrades?
so my personal philosophy is just upgrade everything unless it breaks something, right? Always be on the latest version unless it breaks something.
Oh,
Uh,
interesting.
the reason being, as a result, so whenever I run security checks on our code base, it generally
Right,
points out because we are almost always on the latest versions of every single repo. So we know by hand which are the repos, which are the dependencies which cause problems, and those are deliberately kept at a lower version because we know कि अच्छा इसका higher version has an issue, it has a bug which will probably get fixed later, so we are not going to touch these three dependencies, but the others are almost always on the latest version. Now the reason for this is performance. Many times the upgrades give us free performance improvements,
hmm.
right? A lot of our CPU, right, is not used up by our code. A lot of our CPU and memory is used up by the code of our that our code depends on, our
Right,
dependencies, right? It is in fact in our benefit that we keep everything updated as fast as possible, because the faster we upgrade it, the more compatible we are with the latest versions of browsers, the more compatible we are with everything. Because in the world of browsers, right, everything is changing really really fast, right?
right,
The HTML specs are changing, the JavaScript specs are changing, and if you are on the older versions, what you are doing essentially is you are using some sort of a glue that was put there to support
right,
the older browsers,
right,
right? We want to get rid of that. We want to get rid of that glue as soon as possible because those were older browsers from 2017-18.
right.
Right now, most of the browsers do support the latest specs,
Yeah.
right? So we want to get rid of the older code as soon as possible, and those are transparent to us. We know that, like, we cannot go through all the release documents of all the dependencies, right?
Right, right. It is
But these upgrades do
not
happen,
true. Yeah.
right? So for us, those performance improvements are really, really, really important.
Okay. So in your React repo, do
Uh,
you I assume you don't pin a version. You just say greater than a certain
uh,
version and just let the build.
React is the one library where we pin the version.
Yeah, sure. But the other
Uh,
dependencies,
the other dependencies you don't. So see, whenever we face any issue, and we have faced issues in the past, that
hmm,
is the technique we use. We pin the version. We basically pin all the way to the patch version. We remove the tilde or the
right.
uh, caret from the beginning of the version number, and we say, okay, I just want this exact number. Do not try to upgrade it for me.
Right.
So that is what we have. Even for our internal repos, everything is pinned. We do not want our code to, suddenly start using a higher version of our components unless we want it to, because that is anyway controlled by us. For the external dependencies, the critical repos like 3JS, like React, for them we have pinned versions because we anyway have an eye out for them.
Yeah.
The other ones, the other not so used libraries like Ramda or those uh, libraries for mathematical computations and all, right?
Right.
There we are not so concerned about version because improvements there are the CPU improvements, algorithm improvements, and so on.
Understood.
Nothing really breaks there.
How do you do backend repo dependencies? Front end, I understood that there are a lot of compatibility and speed improvements.
Yeah.
Backend also, do you upgrade bleeding edge always?
No, backend we don't actually. Backend because more often than not, backend upgrades tend to break things more than front end.
I see.
For example, now no one uses Express.js. Express.js is quite outdated now, but
Yeah.
there was a time in the past where we were on Express.js. Uh, Express.js updates or even Fastify updates. Fastify is another sibling of Express.js. It is just a backend server. Okay.
Okay.
So now Fastify has a lot of plugins. One plugin to manage file uploads, for example. One plugin that manages all your HTTP headers. One plugin to manage cookies, right? They have all of these plugins. Now, each of these upgrades tends to break the compatibility with these plugins, right? More often than not, these libraries used to get updated when we were writing a completely new repo for the backend version itself, which tends to
Right.
happen every 3 years or so, right? So let's say we are on Fastify 4.5, right? We almost never move to 4.6 or 4.7 or even go to version 5. The next upgrade that we have had was Fastify 6 because we wrote a new API layer and we let go of the last one. So that upgrade
Interesting.
caused a full upgrade because the trouble with the backend repos, at least that we face, is we have thousands of APIs, right? Thousands of APIs. If any behavior changes in those APIs, known or unknown to us, right? It is going to be a nightmare to fix everything. We do not want the APIs to change their behavior because the way they are built, all the other systems, the UI has been built to work with that specific behavior in mind. Even if there was a more optimized way of doing things, fine.
Yeah.
But with that unoptimized way of doing things, everything else has been fixed around it. So that API cannot really change. The API has to remain stable. It has to remain like that. So yeah, you are right in saying that front-end upgrades are much easier to make, right? It is much easier to stay with the latest version of the libraries
Right.
than the backend versions. Backend because backend is the backbone on top of which everything else is built, right? You do not want changes
Right.
there.
Yeah. I was just wondering, as a startup, how do you think about this? And one argument can be that as a startup, you have very small code base or relatively small code base, and hence it could be easier to go to like newer versions of the libraries. But you also don't have tests usually as a startup, or you have much lesser test coverage because the idea is to run fast and like on probability, the exploratory code is going to be thrown away
Yeah.
in a few months. So until you figure out that this is the code to stay, there is no point doing first class software engineering on it. Yeah, I think that supersedes the at least the backend decisions. But I'm very surprised to know, and it makes sense that you upgrade your front end code in a bleeding edge way to take care of the
So
take benefit of the
I
speed.
think this is different from GMetri because GMetri
Huh.
is a front-end product at the end of the day,
Huh.
right? That is what we are giving to customers. We need it to be as fast as possible, and
Right.
it is not like we are changing things without testing them. Everything gets changed. We test it, and only then we ship it to the customer. The
Got
thing
it.
that is actually difficult to test for us is the backend, right? Because backend we all depend on it blindly. Okay, we know this will work. We know it will work. We to scale it up, all we have to do is horizontally scale it. It will just work, right?
Right.
Our faith is on it. So we tend to stay away from that. Yeah, but if you're really a really small startup, you can iterate on the backend really quickly. But the moment you start building your front end, right, and the moment you have things depending on your backend, it gets exponentially tougher to touch the backend code or to you can add things, but to change the older stuff, you have to be really careful because it's not very clear where all these things are getting used.
Right.
right? You have 5 different repos where the same API calls are being made. You change the API call and suddenly that breaks, right? And you can do it. It will take longer if you
Yeah, I
have
mean,
the
ideally you do
very
it in
well.
a backward compatible manner. So either you
Yeah,
keep this API and just introduce a V2, which is a
exactly.
new API,
Yeah,
and then use it everywhere.
exactly. That is what
Uh,
tends to happen. You just keep adding APIs. You never touch the older APIs,
Right.
because you don't want to change the behavior there.
Yeah. Even if you touch the older APIs, you add things there, and usually
Uh,
don't take things out unless they are deprecated for a while and you know that they are not
yeah.
being used
So the
anymore.
way we have done it is when it gets really old, still then we are scared of touching it. All we do is deprecate the whole repo altogether. We just create a new one, right? And we pick things from it, put in the new one with a different path and everything.
Right.
Make sure our code base works with it. Then we just remove the whole repo. That is still an easier thing to do
Yeah.
than going API by API and figuring things out. That's really really time consuming.
Oh, because you can upgrade the base, let's say React
Yeah,
or 3JS version as well while you start in the new repo. So you just
exactly.
take care of two problems at once.
Yeah.
Interesting. Yeah, I had never thought of just throwing away the old repo. I always thought of upgrading it within the repo. But yeah, this is one cutting edge way of doing it, I guess, in the startup world. What's your React VR story? First of all, what is React VR and what happened with it?
Yeah. So this was around 5 years back, if I'm not wrong. Yeah.
Hmm.
So 5 years back, there were not a lot of libraries like React 3 Fiber that worked on 3JS to help you build things. So 3JS is a very, very low level library.
Right.
It helps you create cubes, 3D geometry, and so on
Yeah.
in the 3D world on a canvas on the browser, right? So it is kind of a 3D builder. But if you have to build something really functional, right? It will take you an immense amount of code to do that on 3JS. It will take you a lot of time. So you don't really want to deal with the intricacies of 3JS yourself if you want to, really kickstart things. So there were a lot of libraries to solve this problem, right? One
Okay.
of those libraries,
What is really kickstarting things? Like, can you give an example?
yeah. So let us say you want a place where you have a video running, right? You want a wall with a video and you have a person standing next to it explaining to you things about the video. One
Okay.
simple experience, right? Now, just doing that much in 3JS in a repeatable manner
Mm-hmm.
is not very straightforward. It takes a lot of things because you need to handle clicks, you need to handle the play and pause of the video, you need to handle, okay, how does the video really play on the browser, how do all the pixels get translated from the actual play into the 3D world, right? All
Hmm.
of that translation takes a lot of effort, right?
Got it.
You can do it on 3JS. There are tutorials online on how to do it. It's straightforward. It is there in the documentation. But doing it every single time for every single experience is not an easy task, right? You need one more library on top of it to make things easier for you.
Okay.
Right. Now, React VR was one such library. It was a library written by Facebook at the time,
Okay.
and it was open sourced, right, for the rest of the world. I think that was the library they were using internally to experiment with the Oculus UIs. At that time, Oculus had just been acquired by Facebook, and they were looking at, okay, how do we create the UI for Oculus? And one of their employees had built this library for that, right?
Okay.
So it was good. It was great. We did a comparison of all the libraries. We checked out A-Frame, we checked out React VR, we checked out other libraries, and we figured out, okay, React VR looks probably the easiest thing for us to use. We'll take that up and try to build geometry on top of it,
Uh-huh.
and it worked. We built geometry on top of React VR. This is, I think, 4 or 5 years back.
Right.
Um, then upgrades at the time for React VR were quite frequent. They were good. It looked like the library is gaining a lot of support. Looked like the right choice at the time. Then they renamed React VR to React XR, seeing that even AR features are going to come into VR. So the term VR isn't right anymore. VR plus AR equal to XR. So they renamed the whole thing to React XR.
Okay.
Things were good until here, right? Then over a period of a few years, I think near COVID time, right? The number of updates started reducing for React XR, right? And it had come to a point that there were no commits to the repo for more than a year now,
Okay.
right? And we were like, okay, ye kya ho raha hai? What is going on?
Ha.
And the performance, right, of native 3JS versus React XR not that better, and that impacted us too. Ki bhai, one of our uh, upstream libraries is doing better and better, but um, we are not getting the benefits. So we had to start writing a lot of code to be compatible with those things of 3JS. So and that maintenance was becoming more and more and more with every passing month. And it came to a point that I think for 1.5 years now, or to 2 years, there were barely any updates to React XR. And then we had to take a call ki yaar, something is wrong. We cannot continue like this, because the number of updates we have to make and the number of maintenance things that we have to do just to be on the latest version of 3JS is getting mind-boggling, right? And it is not something we can maintain. Uh, and our clients had started complaining that bhai, performance is low, something is wrong. The editor had become super heavy, right? You couldn't make really complex experiences on it. And we decided, okay, we have to do something. So we did a full brainstorming session on how big of a rewrite this would be, because this is not a simple change where you're changing from React 17 to React 18. This is not even shifting houses in the same society. This is shifting countries, right? You need passport, visa, sab apply karna padega. This was a really big thing. So yeah, because the whole architecture changes. There's not a
The
single
way you have laid down your code will
Yeah.
change, because the new library might have different paradigms, different abstractions for you to work with.
Yeah.
वो सब change करना पड़ेगा.
So essentially, we rewrote geometry. We knew that this would be a rewrite of geometry from scratch. Well, not the UI pieces, but everything in the back. Everything had to be rewritten. So
Right.
we knew this is a 6-month effort. Okay, so finally, we had to say no to a couple of projects so that we have development time to make this switch. We took the pain, and I remember this was 2020. We took the pain. This whole rewrite happened for around 6 months or so, right? Where first we released a new viewer, and then we started working on the editor, because viewer and editor are two completely separate products.
Right.
Once the viewer was done, the editor was relatively easy because we had the pieces, right? And we could reuse a lot of pieces from there into the editor and do a lot of stuff there. But yeah, the whole thing was a very painful experience. And it was a scary and painful experience, because we were at a point that if we don't do this, we don't know what's going to happen. What's going to happen with our clients? The clients were not happy with the performance. We had to improve our performance. And again, if we don't do it right, if there are a lot of bugs in this, and if this doesn't work out, our future was in question. So we did bite the bullet. We did go through that 6-month phase of changing this. But yeah, once it was out, the performance improvement was so good. It was so good that we are almost at par with as if someone has written a 3JS game in the browser. So the performance was seamless.
Okay, so once you started it, there was no coming back, but
Oh, yeah.
you knew that you had to take that step, however costly it might be, because you're spending too much time in just maintaining the performance of the older library, React.
Yeah.
Got it.
So
What did you move to then?
So there's this new library called React 3 Fiber, right? So we moved to R3F, React 3 Fiber, and that again does the similar number of things that React VR was meant for. It was
Okay.
basically a React layer on top of 3JS. React 3 Fiber is also a React wrapper on top of 3JS. It
Okay.
reactifies it. So essentially, you are working with 3JS,
Yeah.
but it makes it easier for you. So if you have to build a lot of stuff on top of 3JS, your life becomes easier working with React 3 Fiber, right?
Got it.
So we did that complete rewrite. Of course, taking the learnings from the previous React VR experience, we knew what were the things that didn't work with 3JS.
Right.
What are the things we need to build ourselves? So we had that complete picture in our mind.
Right.
So we were able to quickly transition over to this. The first cut was easy, but really making it production ready, really figuring out all of those edge cases, making sure it works good in VR mode, and it works well in all the headsets. The ratios are all correct. Getting those things right also took some time.
Right.
But yeah, and then figuring out the defaults that work for us. So that was really, really important, right? Because the way we make things easier for our customers is we figure out the defaults for them. If you use the
Yeah,
360 directly, there are just too many things to tinker around with to make it
right.
really production ready. So getting all of those things in place, which we had done for React VR, now we had to do for this library from scratch once again, because the everything was different, right?
Yeah.
Those things took time.
Everybody goes through these upgrades. There are usually database driver upgrades or
Oh yeah,
even database version upgrades, which is not your code, but yeah, it's an essential system that you're
yeah,
using.
yeah, yeah,
And after a point, you have to
yeah.
upgrade. Maybe the older version went end of life, right? Um, if you look back to the 6 month journey that you went through to upgrade the library, did everything go as planned? I highly doubt it. What is one thing that you would probably do differently in hindsight?
Oh yeah. Um, so I think what we should have done is probably support the older version for longer. We had done an upgrade of all of our older experiences to the newer version
Uh-huh.
automatically. Right, one fine day we decided to make the release. We had communicated, okay, there will be a major version upgrade.
Right.
The problem was when that major upgrade was done, a lot of the edge features that we have a lot of features. We have more than 100 features that we support.
Hmm.
Now, many of them started behaving differently, right? Because the underlying code completely changed. And this change itself was so tremendous, so huge, that we really did not have time to go through all of those 100 different little features,
Okay.
right? But the problem with that in hindsight was all our customers came back saying, okay, these things don't work, this thing is broken. And then keeping the customers happy, managing those expectations had become a really difficult task at the time. So in hindsight, if we had to do something differently, it would have been this. We should have taken one more month just to, go through all of these 100 features, and instead of our clients pointing out those issues to us, we should have figured those out,
I
right?
see.
So yeah, in hindsight, we would have taken a month or two more just to figure out these small issues.
Okay.
Uh,
Test it better, basically.
yeah,
Right. But I assume there was no backward compatible way of doing this, where
impossible.
let's say you introduce some flag system where it decides that everything points to the old system and slowly start switching it to the new one, because the new one is going to be fundamentally different in the way it works. So you couldn't have done that.
So in fact, we did have that. You had the
Okay.
option to keep an older version and upgrade a few of your projects to V5. We did have that. The problem was that really doesn't solve a lot of issues because your at the end of the day, the final link that your customers give to their customers is
Hmm.
going to be just one. It is either going to be the older version or the new version. It cannot be both. And what was happening was the older version had a lot of performance issues, and the newer version had a lot of feature issues. So they were left nowhere, right? They really did not have an option. What we should have told them is, okay, the older version has performance issues,
Right.
but the newer version is not yet ready. Do not go there. We shouldn't have given them the option to upgrade, right? Until it was fully ready. So we jumped the gun. We gave them the option to upgrade, but that upgrade again caused a little bit of pain to them, right? That we shouldn't have given them the option in hindsight. We should have gone through the pain ourselves, right? Figure out all the remaining issues, fix them, and then give them the option.
I recall you telling me that you don't have a lot of automated tests in your repo.
Yeah.
Did you ever think that you should have invested in tests that would have helped in this upgrade, or probably not because you were rewriting the whole repo, so the tests which were tied with the repo would also be thrown away and they would also have to be rewritten?
The
Uh,
test would have failed, like you are rightly pointing out. The test would have failed. It wouldn't have helped at all because it was such a big rewrite that the test would not work in the first place. And because this is in VR, this is a very visual library.
yeah,
Writing test cases is not very straightforward, right?
yeah.
And maintaining you need someone proficient enough, and you need a whole team of people just sitting there and maintaining these test suites. It's easier right now the stage we are in, it's easier for a person to test it. So right now it
Interesting.
is manual, and manual actually works well. For VR, manual works well right now. If we
Right.
have to do it at scale, we will have to switch. We have figured out how to do it. We have figured out the steps, but again, it requires a full-time engineer, someone really proficient on writing those
Right.
test suites, right? And anytime we change anything, those test suites need to remain updated. So it's a full-time role. Right now, it is easier for us just to have a QA engineer testing it out end to end rather than automating it.
Yeah, this makes me completely curious actually, that in a standard web app, which is not a VR web app, you can do screenshot tests
Yeah,
where
you
you
can.
have the expected screenshot and then you run it and
Yeah,
then you take the screenshot and do a diff. And
yeah,
the pixels will get highlighted, whichever
yeah.
are different. Everything else becomes blank because they are the same. In VR, how, if you were to automate, how would you automate?
So that is the exact way we would automate it. You can simulate. Being in an XR environment or a VR
Mhm.
environment
Mhm.
on Firefox. There are Firefox plugins that simulate a headset, right?
Okay.
So you simulate a headset, take a screenshot, and then do a simple diff. So
Oh, so because you're starting from exactly the same like
yeah,
starting coordinates with some orientation, and then there are precise
yeah.
set of movements.
Uh,
Okay.
and you can also simulate head movements. You can simulate controller movements, right? But the thing is, these things are changing so fast. The APIs to move the controller, for example, the
Hmm.
APIs to point at something and click on it, that itself is changing so fast that us investing our time in writing test cases on the top of those APIs isn't worth it, because by the time we are done with the test, the API would have changed. We would rather just keep our code base updated with the latest API of using a controller
Right.
than updating the test case for it, right?
Yeah.
So that is why that is a precise reason why the test cases right now manually make a lot of sense. Let
Hmm.
the whole ecosystem stabilize. Let us enter a world where these APIs don't change for a year or so.
Right. Right. Right.
Once we are in that world, then we start automating these test cases.
Yeah. Also, if I think about it, the screenshot test is probably like not a very good way to do it because in a VR environment, if the output changes slightly,
Hmm.
it's okay. A human is perceiving it, so you don't have to be pixel perfect in rendering the thing exactly how it was before. But the performance, the snappiness of it, how smooth it is, all of that actually matters a lot more, which is a lot harder to measure automatically. So again, a human does the job better.
Yeah. So the QA engineer points all these things out. Okay, okay, things have become slow. Something is wrong.
Hmm.
Test cases में simulating that will take us time.
Yeah, and it's quite hard to maintain as well. Interesting. Uh,
Not
okay.
automating test cases. Huh?
Yeah, this is
Yeah,
this is like one scenario where automating test cases, not automating test cases, is
does make
actually
sense.
a better idea. Yeah.
Yeah.
Uh, okay. With that, I think we'll close the conversation. Thank you for joining us today, Sahil. Love chatting with you the second time.
Thanks, Bhavan. It was a pleasure.
Thank you for watching the whole video. Since you watched the whole video, you are a true hustler for your professional growth. Please subscribe. Please like and share this video in your professional network. Please comment down below with suggestions and topics that you would like to hear about. Have a great day ahead.